Right, so today we're just going to look, it's a very short, sharp topic. We're looking at recurring decimals to fractions. But first of all, we've got to think, what is a recurring decimal? So a recurring decimal has an infinite number of digits. So the digits after the decimal place repeat. So the digits after the decimal place recur. So for example, you could have 0.55555 and so on, 0.8. And then if we said, let's put the one that recurs, 33333, not every single number does, but we could do them in blocks. So we could have 0.356, 356, 356. These are all types of recurring decimals. The recurring digit in a recurring decimal can be indicated with a dot over it. So we can write that as 0.5 with a dot. We could write this as 0.83, but the dot is on the 3. And in this one, if 2 or more digits recur, the dots are placed on the first digit and the last digit in the repeating pattern. So in this pattern over here, the dot is going to be put on the top of the 3 and on the top of the 6. So, for example, let's take one more example. If we have 0.64 and then 589, 589, 589, so that's the bit that's recurring. We've got 0.64, 589, but the dots are on top of the 5 and the 9 because those are the first and last digits in the repeating pattern. So this comes up in the exam papers. There's nearly always a question where you want to convert a recurring decimal into a fraction. So let's look at a few of these. So let's say we want to convert 0. Let me put it in a different color, 3333 and so on. So what we say, and you've got to write it, this is your correct notation. We want to call the recurring decimal x. You might have done it and called it n. It doesn't really matter what you call it. It depends on how the question words it. It might say let x, show that x equals, show that n equals. Depending on what they've called it, that's what you're going to do. But for the purposes of this question, we're going to say let x equal 0.3333 ... In this case, because it's just one thing that's recurring, I'm going to times it by 10. So I'm going to multiply. So I'm multiplying by 10. So 10x, remember we multiply by 10, we move the decimal place 1. So 10x will be 3.3333. And if you notice, the thing after the decimal place now is the same. So if I call this 1 and I call this 2, I can do 2 take away 1. So I want the bigger one take away the smaller one. And that will leave me with 10x minus x, which is 9x. And when I take away the other 2, those 0.333 bits all just cancel each other out. So all of this disappears and it just leaves me with 3. And so I'll get x equal, divide both sides by 9. So divide by 9 and divide by 9. 3 over 9. I can cancel that down and I get 1 over 3. And you could double check it. You could stick 1 over 3 into your calculator and you should get 0.33333. Right, so let's take one of each type. So now we're going to convert x equals 0.818181 and so on. Right, so exactly the same steps. We're looking at it, we're not really sure. Essentially, we want to end up with something where everything after the decimal place is the same. Now, if we were to times it by 10, I would end up with 8.181818. And if you notice, this is not the same as this. The whole aim is to get that bit the same. So you keep multiplying by 10 until it's the same. So now I'm going to multiply it by 10 again. So move it up 1 decimal place. And now I've got 81.818181. And I can see now that this bit here is identical to this bit here. So if I call this my 1 and this is my 2, I can now do 2 take away 1. So if I write them on top of each other so it's easy to see, equals 81.818181, and we're taking away x equals 0.818181. And what we'll end up with is 100x minus 1x to give us 99x. And then that's 81 because we're deleting all the rest of it. So x is 81 over 99. And we can simplify that, divide top and bottom by 9. We're going to end up with 9 over 11. Okay. So let's take one where it doesn't necessarily, let's take a few stranger ones. So just flipping through exam papers to try find some. Okay. So if I have x equals 0.14444, right, so I look at that and I go, okay, if I times that by 10, what happens? I've got 10x is going to give me 1.4444, okay, which doesn't look the same, so there's not the same, so nothing's the same yet. So I'm going to do it again, I'm going to times it by 10 again. So I've got 100x, which will be 14.4444. And now if you notice, this and this are the same. So that means these become, if you like, my 1 and 2, which I can take away from each other. So I can do, that's 1 and that's 2. If I do 2, take away 1. On one side, I've got 100 minus 10. So I'm going to get, on this side, I'm going to get 90x. And on this side, I've got 14 take away 1, which gives me 13. And that whole pink bit disappears because it's all exactly the same. So x equals 13 over 90. So the only skill you need to be able to do this is to keep multiplying by 10. So you keep timesing by 10 until that bit after the decimal point is exactly the same. So let's see if there's, okay. Right. And I don't think there's any other real types that you could get. Let's say there were 2 numbers that were same. Let's just do one last example. So if we have x equals 0.67459459459, so I can see that my recurring bit is this, but I want that to be the only thing after the decimal place. So what we're going to do, well, if we multiply it by 10, hopefully you'd see that you're only getting rid of the 6. So we're going to multiply it first by 100. So 100x is going to move this 1, 2 decimal places. So you're going to get 67,459,459,459. And now, without having to do 10, 10, 10 again, you know that you'd have to move the decimal place to here for everything to be the same. So you're going to have to move it 3 more. So you've got 100 times by 1,000. So you've got your 1, 2, 3 more, and that would give you 67,459.459,459, and so on, which doesn't look so nice, but remember you do have calculators here. So now the whole of this is the same as the whole of this. So we can do 2 take away 1. So when you've got 100,000 and you're taking away 100, you're going to get 99900x, and you've got 67459 minus 67 to give you 67392. And remember, this would, if you got something this long, it'd been a calculator paper. This is just a bit of an extension. Divide both sides by 99900, 9900, giving you x equals 67392 over 99900. And your calculator, if you stick that in, will simplify that for you and give you 624 over 925. So that very quickly is one little tiny topic, but it's 4 or 5 marks in the exam, and I think they're quite easy marks if you follow the steps. So that's converting recurring decimals into fractions.